Okay. I guess it's time, so I'm going to go ahead and get started here. Thank you all for choosing this session of the many the three you could have chosen at this time slot, because there's some good ones, and I was kind of disappointed to be at this time slot for my own purposes and seeing the other speakers. So we're going to talk about Docker today. I will do a brief introduction to myself first, so you know who I am. My name is Karl Hughes. I'm the CTO at a little company based in Chicago called the Graide Network. What we do is we have a network of graders who grade papers for K through 12 teachers. So our app is mostly CRUD, mostly doing a lot of pass-through. Teachers upload assignments. The graders then get that student work, and they grade things in our application. We run on PHP. We use Laravel, I think it's 5 or 6 Laravel microservices, and Angular 6 now on the front end. Just finished that upgrade, which wasn't fun. But last year a couple years ago, I was on a team doing similar stuff with PHP microservices, and we were having a really hard time figuring out a good way for our developers to have consistent environments, especially with local development. And I think anybody who's done any sort of PHP app at scale and then tried to replicate that on their local system has probably run into some of these challenges. So we were using virtual machines for a while. I think there's some great stuff there, although they sort of hit some limits. I started exploring Docker a couple years ago, and then I realized that was sort of my way forward. And so that's how I've been doing local dev for PHP and any other language pretty much since then. And then last year I got really inspired, and I wrote a little book that you guys can get for free on my website, which is shipphp.com. I'll have a link later. It's called Building Your First PHP Application in Docker, and it basically mirrors what this presentation is. So if you like this presentation, but you didn't quite follow everything, or the slides aren't enough, because I don't include all the code samples here because it's a little tough to read code samples in a 45-minute presentation. But if you want that, the book's free. You can download it, so go get that. And if you don't like this presentation, don't get my book. Go find something that's better, because there's lots of great resources on Docker at this point, and I am by no means the best, most qualified person in the world at it. But I like it, and it's fun. So this is what we're going to talk about. We're going to hit kind of the high points of what Docker is, how it might be used, some of the really good use cases, as well as some of the trade-offs you make when you choose Docker as a platform for local development or in production. We won't get too much into production level stuff in this talk. I mean, I'll touch on it, and I would be happy to talk about it more if there's questions. But typically what we're going to do, or sort of the bulk of what we're going to do, is run through the basics, where we're going to run an actual PHP script using Docker, and then we're going to run a small PHP application with a couple different containers linked together using Docker. There's a lot of ways to do this stuff, so I'm running through one way, and if you sort of have a question or you've seen it done other ways, feel free to raise your hand and interject, because I think that's one of the challenging things about any new technology like Docker. It's relatively new on the scene, so there's multiple ways to do things, and people are still figuring out best practices, so we can have discussion about it. That's great. So that's what we're going to do. First of all, how many of y'all are using Docker at this point, for local development at least, or something like that? OK, cool. Anybody running it in a continuous integration kind of or dev environment or something? OK, cool. That's my sweet spot for Docker. That's where I think it's really good. And then anybody running in production yet? Awesome, good. Well, we can all geek out about that stuff then. Good. So I've done it a little bit in production for side projects. I have our dev environment all running in Docker at the Graide Network, and we're sort of toying with what it's going to take to get our prod ready and running and feeling good about everything, because it's always a little bit more of a big switch to flip. So Docker has really taken off in the last 3 or 4 years. And it's interesting, this data is over a year old now, so this is from Datadog, and they do a lot of monitoring for servers, and so they look at Docker adoption. They saw it go up 40% between 2016 and 2017, which is a really big jump, and it's continued to go up from there. What I think is really interesting about that, because, I mean, hype trains do this, right? They go up and down, and that's not something we have to pay that much attention to. What I think is interesting, though, about Docker is that larger companies tend to be leading this adoption curve. And part of the reason for this is that for enterprises who come to the table with a bunch of their own machines, systems, servers, all in place, it's really hard to adapt something like a PaaS, like Heroku. Y'all familiar with Heroku? It's really cool if you're in a startup and you want to just spin something up and put it out in the world. Do it in Heroku because it's super fast, super easy. Gets expensive, but it's just no DevOps work at all. But if you're an enterprise company where you've got your own on-premises servers and you've got security rules that are pretty restrictive and you've got sort of a way of doing things, you can't just go start using Heroku. You can't use all the cool latest stuff for deploying your code. Not like that, at least. I do see more and more enterprise companies moving towards cloud computing, which is great because that gives you a lot of flexibility. It's a lot cheaper in most cases. But what's cool about Docker is you can run it on your on-premises stuff, or you can run it in the cloud, or you can run it as in a dedicated Docker hosting environment. So we can have different levels of adoption. I think that's why we're seeing it take off pretty quickly, regardless of the size of the company. How many, I guess, of those of y'all using it, how many are using it company-wide? Like it's kind of the standard for development or local development. Okay, so that's cool. Yeah, because I see a lot of companies that are, it's kind of like one developer using it locally as well. So I don't know what these numbers include. If they include like large companies that have at least 5 developers or 1 developer using it, that might be a way to game these numbers. But regardless, Docker's taken off. It's gotten a lot of popularity. And that's cool and all, but like I'm not the kind of person who jumps on hype trains just because they're cool. There are people who do that kind of hype-driven development, as we call it, and I'm not a big fan of that, being like more in the sort of role between business and technology. I'm always trying to avoid jumping on things too early, but at the same time, Docker is one of those technologies that does bring a lot of benefits to the table. So let's talk about what it is so that you can kind of see some of these benefits in action. How many of you have used virtual machines for local development? You've set up like VirtualBox or VMware? Yeah. Okay, so that was, I think, pretty much the standard until Docker got more popular in the last few years, at least in my circles of PHP developers. I'm sure there's other, you can install everything, hard installed onto your Mac. That's fine too, but it's pretty inflexible. So typically with a virtual machine, you're going to spin up this whole virtual machine. It's going to have PHP, MySQL, the web server you want, Nginx or Apache, all hard installed on the virtual machine. You can create an image of it and then share that image with people, which is great. But there's not a ton of granular flexibility when it comes to how you set up a virtual machine. And that's where Docker differs quite a bit. And one of the big concepts you have to get your head around when you start running Docker containers is that each container is a single process. So whereas in a virtual machine, we may have dozens of processes running to get the whole web application running, each Docker container is running one single process. So one instance of PHP is one Docker container. One instance of MySQL is one Docker container, et cetera. And so in this case, you can see we've got 3 instances of PHP running, each in their own container, all within the Docker network, so that they can all be called through our Nginx, which is acting as a proxy in this case. So that's a big part of the difference between the two technologies. What I like about this with Docker is that it allows us to start and stop each of these containers very granularly. So whereas a virtual machine, if I want to change some configuration about PHP to get more processes running, I've got to go in, change the PHP FPM config, and mess with a bunch of things, and then restart the virtual machine. With Docker, I can just pull one of those containers out of sort of the rotation. In production environments where you need to scale up and down pieces of your application granularly, this is really helpful. It's also kind of helpful locally if you want to see what's going to happen when we put our app behind a load balancer. Maybe you're moving from a single server to multiple servers, and you just want to test that out. It can be really helpful there. It also can be really helpful when, let's say, we want to introduce a new service. I think more and more we're seeing these infrastructure services that are doing a lot of work that we would have had to write ourselves. So for example, Redis is a good instance of this. You don't have to maintain your own key value store cache with Redis. You just use Redis as a service, and you just call into Redis's port whenever you want to save things to a key value store. Super handy. I mean, you can do this in MySQL, but Redis is really built for this. So it's a lot faster, a lot more performant, and just kind of easier to work with if you're doing key value storage. The downside to using Redis in a virtual machine environment is that you've got to go install Redis. You've got to configure it. You've got to figure out how it works to the level where you can sort of build it into your virtual machine. You've got to make a new copy of your virtual machine image, and now you've got all that saved. With Docker, we can just spin up a Redis container linked into the other containers we've already got running and see how it works together. So it's really fast to get that kind of thing started up. And as we get into some real examples, hopefully you'll kind of see how that goes. Another thing I really love about Docker is that you can track your configuration both at the individual container level. So you can use Docker images that are shared between your teammates or between your local host and the server to make sure that you're running the exact same infrastructure for each one of these running containers as you are locally out in production. And you can also track the configuration of all of your containers together. So Docker Compose is a tool they released that allows you to basically start and stop batches of containers together. And that's typically what you're going to use in a real PHP app when you're doing local development, because almost never are we doing a PHP app that's so simple it's just one container. It's almost always several containers. We'll see that in a few minutes as we get into the talk. So that tracking of configuration, what you can end up doing is saving your config file, your Docker Compose YAML file, to your actual version control system and uploading it into your Git repository, and then everybody who downloads that project knows they can run one command to get the whole app up and running on their local host. So that's super helpful when you want to share those things. In our case, what we're doing a lot of times is we've actually got several containers for several different PHP apps all starting up at once. And so it's a bunch of Docker Compose files layered on top of each other. So it can get even more complicated than that if you've got a really big, complex application. Or you can actually just start little pieces of the app at once, which is handy if you want to just, say, work on one microservice in a suite of 10 or 15. So I've already talked about some of these pros, but I haven't really explicitly mentioned everything here. Another big difference between how we run containers and virtual machines is the speed at which they start. So a virtual machine with a lot of stuff installed might take a couple minutes to get going, depending on what your hardware is like. Docker containers typically take 2 or 3 seconds once you've got all the images, so it's really fast. And I kind of talked about this, touched on it a bit, how I like it for continuous integration, but this is one of the reasons I like it for continuous integration, is that I'm not paying for those compute cycles while it spins up virtual machines or whatever. Instead, I'm just going to spin up a bunch of containers at once really quickly, and it's going to run my continuous integration through it, and then everything's good and it's going to deploy. It's also really easy and fast to scale up your system of Docker containers to whatever you need in production environments once you get to that point and you're ready to deploy things. I think that's not always something that we need. A lot of times people think, us in the development world think we need scalability and flexibility a lot more than is probably really necessary. If your app's traffic is pretty steady, or you have like 2 spikes a year, then maybe this is a little bit of overkill at this point. But if you have this like hourly or daily fluctuation, like some apps do, it can be really helpful to sort of smooth out that load and not pay for pay for your peak usage all the time. The downside, like any new technology, we've got fewer best practices to work from. So this is getting better, obviously. I don't think this is quite as true as it was a couple years ago. But it used to be that nobody was really sure how to run containers in production. Now we're at a point where I think people are pretty sure they're doing it in the real world. And so there's a lot more blog posts about how you can actually do it successfully. So I worry a lot less about this than I used to. But it is something to think about when you start getting into it. And the other thing you have to think about is security. So even though you've got this container, which I guess I'll back up just a second, say what a container is. Because I didn't really realize this until this summer when I went to a talk that was about sort of how Linux containers work, and I started to get a better idea about what's going on. I'd kind of always thought of Docker containers as this magic. I just say Docker run, and boom, I've got a container. Hey, it works. I don't care how it works. I just wave my hands. So is anybody familiar with Linux containers? Has anybody heard of that before? So I'm not a Linux admin. I have to do a certain level of sysadmin stuff, but I'm not good at it. It's not my calling in life. So Linux containers have been around a long time, and the idea of a Linux container is I can cordon off pieces of the operating system's resources, maybe it's users or file system pieces or piece of memory or whatever, into these containers that have their isolated environments that don't get access to the full host file system, just the resources we want to give them. So those have been around a long time, since Linux, as far as I know, since Linux has been around. And so those have been available. The challenge has been that running them and keeping them going and making sure they're organized has been difficult until the last few years with Docker. And there's a couple other container sort of platforms that are similar. So anyway, Docker hasn't really completely given us a brand new technology. It's more like they marketed technology that already existed way better than anybody else had, and they sort of packaged it up nicely, which I'll give them credit for that. Anyway, so even though we're running these isolated containers, there are security considerations to make. And so anytime you are running a Docker container, that container has the possibility to access certain resources on the host file system that you share with it. So you have to keep that in mind. You can't just assume that Docker container is completely isolated and no one will ever be able to crack into your host system through it. That's possible, and there are ways to do that. So kind of know what you're doing before you get too far in that. You also have to think about the sort of permissions that each one of those containers have with each other. So maybe your PHP container has access to the database container, which you need, but you also have to think anybody that gets access to your PHP container by virtue of that also has access to your database container. So there may be some sort of bleeding permissions there you want to keep in mind. The places where I see Docker shining most are situations where you want to or need to try multiple versions of a database or PHP as a language. So for example, I was working on a project, open source project called PHP CRUD API a couple of years, maybe a year ago. And the guy had written this, it's like a one PHP file that'll read any SQL database and make it into a RESTful API. So it's a cool idea. I love novel things like that. And so he wanted to support and is supporting SQL Server, MySQL, Postgres, and SQLite, and every active version of all those databases, and every version of PHP from 5.5 on. So that's super hard to do because they all vary quite a bit in that range. But also it's really hard to test for. So he had tests, and he was basically just running them in virtual machines. So he had 4 or 5 virtual machines to try different configurations, but he couldn't test anywhere near all of the different combinations. And so I started working with it locally and figuring out how we could set up some containers to run more of those situations together and then run it in Travis CI for continuous integration, so we could, every time we made a change, we knew that it was going to pass on at least most of the combinations. Now there's thousands of combinations of all that stuff, so we don't do everything, but it's a start. And if you are in a situation where you're maintaining an open source library that needs to support several versions of PHP, I think containers are a really great way to handle that. If you're dealing with problems with consistency across machines, Docker can be a big help. So even if your developers are all working with similar virtual machines, there's the potential that each of them can come in there and tweak things or not get an update or whatever, and Docker can help with some of that stuff. You still have to have a certain amount of awareness of what's going on in order to stay up to date, but I think it's easier, especially with Docker Compose, checking those into version control. Continuous integration environments, I already talked enough about that. And then when you've got granular resource scaling. So for instance, I've got 5 instances of PHP that normally run, but on peak times I might spin that up to 7, and then slow times I might go down to 3. You can get Docker orchestration systems that automatically do all that. So it can basically watch the load on your CPU and see what that's at and then scale things up and down. Pretty cool. Kind of complicated to set that stuff up, but if you're in a situation where that's going to save your company millions or thousands of dollars a year, then you might want to think about it. All right, so let's get to the meat of this. Before I start on some actual samples of what Docker looks like, anybody have questions that came up from that first bit that you are burning and you need to ask right now? Okay. Nobody. Excellent. Good. So you all understand all the fundamentals of why we would use Docker. You're all ready. Everybody ready to use it? Yeah? Okay. I'm getting mostly nods and thumbs up. That's good. I got a couple dissenters, which is great because I love to have dissenters in the room. So let's run a PHP script in Docker just to see what it's like. First of all, this is just PHP-V, which just shows you the version of PHP you're running. So this is not even a script. This is just a built-in language construct. But I'm going to run docker run. So assuming you've got Docker installed, I kind of jumped over that step just because I'm hoping you get that. But Docker's installed. So from the command line, we say docker run. And then I say php:7.2. What that's telling Docker is use the image called PHP 7.2, which, as you can imagine, is PHP 7.2, and then run the command php-v within that container when it runs. And so pretty straightforward. You're going to get Docker, or you're going to get PHP 7.2 CLI. It's going to tell you some other info about the version of PHP you're running. If you want to try this with a different version, you just change 7.2 to 7.1. You can also change it to 7.1-Apache to get a slightly different variation on that. There's a bunch of different Docker images. We'll talk more about images and containers, what they are, but just know that's how we get the version of PHP in Docker. Now, if we want to run an actual PHP file, so that first example is not really that useful, but this is a little more useful. For example, when I want to pull down somebody's PHP script they wrote, maybe a command line script, and I want to run it in several different versions of PHP, I might do something like this. What I'm going to do is docker run, same starting point, and then -v, and then the $PWD is present working directory if you're not a bash expert, and I'm not, but I know that means present working directory, :app. So what that's going to do, that -v part, is mount a volume. So this takes the files in your present working directory and puts them into /app in the container itself. We'll talk about what volumes are in just a couple seconds, so just hold on to that thought. And then finally, the command we're running is php/app/hello.php. And that's just the hello world script I wrote, and it just says echo hello world, so I'm not going to show it just because it's not that exciting. I imagine you all have written plenty of those. So that's running a simple PHP file. Now, what did that volume thing do, and why did we do that, is probably the next logical place to jump. So like I said, Docker containers are isolated from your host system, and that's by design. That's a good thing. Typically, a Docker container does not get access to the files in your host file system unless you give it explicit access to them. So that's good. We don't want PHP containers running wild in your host machine and grabbing stuff out of your local box unless we tell it to. So they're isolated. But what we can do if we need to get files from the file system into the Docker container is we mount a volume. So the idea of a volume is another kind of Linuxy container, or container thing that Docker's basically adopted. And there's several different kinds of volumes that Docker offers. The kind we're talking about here is a bind mount, which just means bind a directory on the host system with a directory in the container. And by default, it's going to be a two-way binding. So what's handy about that is if I change some code locally in this directory that I'm mounting into the container, it's going to automatically update in the container itself. Similarly, if the container updates that code for some reason, it's going to automatically update to the host machine. So be aware, you've now given the container access to change files on your host machine, which could be good, could be bad. Don't mount your sort of root directory on your file system into a Docker container unless you know exactly what's going on there. So typically, you want to do this at like a project level. So if you clone a project from the internet and you're going to play around with it, you want to run the script, you just mount the project as a volume into the container and then run your PHP commands in that container. That makes sense? I know volumes took me a little bit to get my head wrapped around, so happy to answer questions if this isn't all clear. I'm seeing lots of good head nods. Awesome. OK, so let's build something a little more meaningful here. We've so far just talked about running one single container, which is great, but it's also not very realistic, again, unless you're running one single PHP script, which maybe we're doing. We're playing with some open source stuff, or we're just writing a little bash command. But typically, when we're working in PHP web applications, we're going to run a database, we're going to run PHP, and some kind of web server. So that's what we're going to build here in this next section. But first, let's take a little aside and talk about how containers get made. They're not brought by storks with weird bills. So the way that we go from there's three artifacts in Docker that get thrown out there, and I've already thrown a couple of these out there and not explained what they are. So I apologize, but I wanted to get to a good point before I started to share the specifics, because these are also a little bit of a tricky concept to get your head wrapped around at first. So how it starts is a Docker file, which we'll look at in just a second. But the Docker file is basically going to specify what version of Linux we want this container to run on. It's going to specify what programs are installed using apt-get or whatever package manager Linux you use. It's going to copy code files from your host machine into the container, or Docker image, sorry. And then when you say Docker build, it takes this static Docker file that you've created and turns it into an image that Docker saves in its own little dedicated file space on your system. So this is another weird thing about Docker, is that it seems to create all these little artifacts and put them out somewhere, and you're like, where did that thing go? They're actually getting saved on your local host somewhere. They're just not in a place where you could easily find them. So technically, if you ever want to clear out what Docker has, there's ways to do that with Docker. So there's like a system prune command. And you'll find that Docker has eaten up 8 gigs of your hard drive over the last couple months. It's pretty much every time. So get ready to do that occasionally if you've got hard drive limitations. But storage is cheap these days, so don't worry about it. So we start with a Docker file. It's got some specs for how we're going to build a Docker image. So we're going to then use the Docker build command, and we'll talk about what flags we can use to pass in for that. And that's going to create a Docker image, which gets saved, once again, to the local Docker space. And you just can look at all the images by saying Docker images, and it's going to list all the images you've got and their names and sort of their hashes, which is just Docker's way of verifying images. And then finally, there's the idea of a Docker container. And so I've been talking most about containers, but essentially a container needs an image. That image specifies sort of how that container is built, or what's running in that container. And then the container is the actual running process, essentially. So we run a PHP container, but we've built it from, or we've run that container from a PHP image. So once again, we'll walk through all the steps, but it's a little bit weird to wrap your head around. I still feel like I'm learning how to explain this best, because it's the harder part of this. Anybody have questions on this so far, though? Y'all with me? All right, excellent. I'm doing better than usual then. Good. So let's build a custom PHP image. There's a lot of cases where you'd want to do this. The first is if you are going to install any PHP extensions that are not installed with PHP by default. So default is sort of an arbitrary term, but in Docker Hub, which is the place where Docker images are stored, there are official PHP images, and those official PHP images might come with Apache, and they might come with just the CLI, or they might come on different flavors of Linux. But they don't typically come with things like a MySQL driver. So if you need that, which most of us are going to need some kind of database driver, you're going to want to build your own PHP image on top of what you started with there. So fortunately, this is not as hard as starting from scratch, because Docker comes with some constructs to let us start at any given point in a Docker image. So what we're going to say is from PHP Apache, which is the default PHP Apache image. It's already got Apache configured and built, ready for PHP. It's got PHP with all sort of like defaults going. We can then install any PHP extensions we want. So in my case here, I'm just installing MySQLi, which is a interface for MySQL. You can also, well, like I said, you can do Postgres, and you can do, there's dozens of other extensions. Whatever extensions you need, you can figure out a way to install here. And then you can also upload, so I didn't include this step, but if you wanted to do things like copy over any php.ini files from your local host into this container, you could do that here. That would be a good place. You can also copy your code from the present directory into that container. So before, when we did a bind mount, that's a two-way volume. So it's a two-way passage of data, which can be good for local development. That's fine. But when we're going to push this thing out to the real world at some point, like to production, we don't want a two-way movement of data between the container and the host machine. Reason for that is we don't have our code on the host machine anymore. The code is just in a container. So typically what we want to do then is copy things as we're building this image from the local machine where we're doing the building into that actual PHP image, and then deploy them as a running container. And that host machine has no idea or doesn't care about those files in that Docker container that's running, which is pretty cool. So if that container ever gets corrupted, someone gets access to that container and they change files, next time you rebuild and deploy that container, they'll all be gone. It's overwritten. So there's some advantages to that. So this is how we get, this is a Docker file. This is a really simple, just 3-line one. And that's kind of what it's doing. If you want to see an example of this in action, like I said, I'm not going to fill in all the PHP code just because you guys are PHP devs. So I'm going to assume you know a little of that. But if you want to see it at github.com/shipphp/weather-app, there's a whole little application I'm running all these examples on. And there's better details on how you can run it yourself. So feel free to do that if you want to follow along. So we've got a Docker file. And remember, the next step is to build a Docker image. So we say docker build -t, which tags that Docker image with a name. And in this case, we're using php-docker. So you can pick any name you want at that point. I picked the name php-docker because it's pretty self-explanatory for my local use. But in reality, if I were going to push this up to Docker Hub, I might want to do something like Karl Hughes /php-docker, so that it's differentiated from other PHP Docker images. So that's kind of a typical best practice. And then the // at the end is the path to the Docker file that we just created. So it's just a relative path. And if you're assuming you're navigated in bash to that directory, it should be // for you as well. Now, before we get into running, anybody have questions? Nobody. This is awesome. You guys are just pros. We're going to get to talk about all sorts of fun stuff at the end here then. Good. I love it. So once again, we'll just look at this journey again, because I don't want to assume anybody, I want to assume that somebody didn't get it. So we've got a Docker file. We built that into a Docker image. That image is now living in our local host in the Docker file space. We can look at all the images by running Docker images from the command line. It's going to list them all out, and we should see this one called php-docker that we just created. And so it's available. Now we want to get it into a running container, a process that's running that we can actually use. So docker run -p 8080. So the only new thing here, we've already looked at what docker run does. PHP Docker is the name of the image we want to run, and so it's just that image that we just created. So php-docker, pretty explanatory, I think. And then -p 8000:80. What this is doing is mapping a port from the Docker container that's running on port 80 of that container to port 8000 of our localhost. So this is another thing that sort of, I don't want to say blew my mind, but it was just interesting to learn about how Linux containers work. Linux containers and Docker containers, by extension there, are isolated and don't have access to the host's ports by default, which is good. We don't necessarily want Docker containers to spin up and automatically have access to deploy things onto ports on our running host, right? So if you want to have that happen, what you have to do is map the ports from the Docker container to your host. So this is basically the equivalent. I'm going to say this, and it's going to be like, that's technically not right, but if I'm thinking about it in like sort of layman's terms, it's the equivalent of mounting a volume of files, but doing it for ports. So we're saying map the localhost port 8000 to this container's port 80. If that makes sense. And I could have mapped it 80 to 80, which would have been fine, assuming my localhost doesn't have anything running on port 80. By default, a lot of machines come with something running on port 80, or it's restricted, so I typically won't run things on port 80 unless there's some weird need to. But if you were going to maybe run this in a production environment, you might map port 80 to 80, maybe, depending on how your setup is. So this is going to bring up our little PHP application that we just built on localhost 8000. So we all know that good feeling of when things work, and that's what you hopefully have at this point. All right. So that is the process for getting us from a Docker file to a running Docker container. There's obviously a lot of complexity that you can add into those different steps. So there's tons of like sort of, I guess, little pathways we could talk about at the end of this talk, but that's kind of the basic process to get you started. Now, obviously, one container running. Once again, we're just running one container, so it's not super exciting. The reason I wanted to show you that is because we needed the MySQL extension installed in this PHP container so we can actually connect to a database. So let's take that container down, and there's a command called docker stop, and then you put the name of the container, and it'll just shut it all down for you. And let's actually start this process over, but let's do it from MySQL as well. So normally, if I were going to install MySQL on a virtual machine, didn't have it yet, well, I would probably go to find a virtual machine image that already had PHP and MySQL, and then I'd just start there. But if you wanted to do this, you would install MySQL on the machine. You'd choose a port and a database name and all this good stuff. And it's not too bad, but every time you want to change the version of MySQL, you basically have to reset this process, which is kind of a pain. Migrating data can be a bit of a tricky business as well. And then you're pretty much stuck on that version of MySQL anytime you're running this virtual machine, which can be good. But let's say you want to do it with Docker. The cool thing is you can choose any version of MySQL to run, and you can mount the same data. And assuming the data structure in MySQL hasn't changed, which between minor versions it won't, between major versions it might. But assuming it hasn't changed, you can mount those files, the actual MySQL data files, in a volume from your host machine into that container. So a lot of people, have you all heard the sort of don't run your database in a container thing? I don't know. That was going around for a while. Maybe it's a little less prevalent now. While I don't necessarily think it's a good idea, it is doable. And the reason it's doable is you mount the actual data files in a real virtual machine or real physical machine, depending on what your setup is. So you've always got those files. They're not going to go away even if the container shuts down or Docker completely craps out, which is rare, but it happens. So anyway, the point there being that we want to start a MySQL container, and we want to mount our files that are going to actually save the data into a volume. So let's do that. This is all really similar to how we did things in PHP. We say docker run. We're going to map port 33060 to 3306. Now, by default, MySQL is running on 3306. A lot of machines come with MySQL running or something on, or 3306 is already restricted. So a lot of times I'll run this with 33060 just to be safe so that people don't have port collisions. And then -e MySQL allow empty password. Now, don't do this in any sort of production environment or any environment that has any ports open. But if you're just doing local development, this is a quick way to get your MySQL database running with no password. You'll run into the same problems the Mongo people have run into if you run this in production. But basically what you're doing here is you're just telling Docker, when you run, add a environmental variable called MySQL allow empty passwords to set it to yes, and that tells MySQL to allow empty passwords. So it's the same as setting an environmental variable. And if we wanted to set other environmental variables, we could do it right here. I'll show you another way in a second, but this is one way to do it. You could do the same thing with your PHP app when you run it in a container. You can do this -e and set all your environmental variables right there. So that's handy. The next couple lines here are to mount a volume. So again, I don't want to trust necessarily that a Docker container will always be up and will never stop and get reset, because there's a lot of ways you could accidentally reset a Docker container. So I always want, if I've got a persistence thing like this, I want to make sure I'm mounting a volume. In this case, I'm mounting a directory called db-volume into where MySQL stores actual database files. And so if I ever take down that MySQL container and start a new one, it's fine. I just mount the same volume, and I've got the same data automatically, which is pretty handy. And then finally, I want to name this container. And the reason for that is it's a lot easier to connect and link containers together when you name them. You don't have to. This is optional, but it also is helpful when you want to know which containers are running where. I'm just calling this one DB. You can call it whatever you want. If it's just running locally, you shouldn't have collisions, name issues, and all that. Good. So we've got a MySQL container running at this point, and you could go ahead locally and connect to it through your whatever PHP MyAdmin or DataGrip or whatever you use to connect to databases. Then if you want to link that same PHP container that we just ran, let's say we stop it, take it down, then we run the same command, but we add --link db, which just links this container to the db container. Then you're going to be connected, and you should have everything working with data. Yeah, so that's the process for doing it container by container. Now, yes. Yes. Correct. Yeah, you should have the database container running first. Yeah, of course. Sorry, I got too excited about showing data. I'm a nerd. All right. So I guess this is a good point to bring up. When you run multiple containers and you're going to run them with Docker run, you're going to need to make sure the one that is the most depended on runs first, and then you're going to have to kind of build your dependency tree up like that, if it makes any sense. Go ahead. When you what? Yes. Yeah, exactly. So like if you were, yeah, I mean, if you're building up any kind of operating system or something from scratch, you always want to start with the lowest level dependency first. So in our case, MySQL is, like all PHP containers will depend on MySQL, so we'll probably have to run it first. And then probably any other persistence things like Redis or Memcache would also want to run those first. Then run PHP like containers, and then web servers maybe on top of that, or any kind of routing layer or whatever. Yeah. So that's complicated to do on your own, obviously. Yes, you can. So there's a flag -d that'll run these things in the background. Yeah, and I didn't include a ton of the options. There's tons of options with every one of these Docker run commands that you can use. Go to Docker's documentation. It's actually really thorough, really good. I mean, like I said, Docker is a big marketing ploy, and it really is good at marketing. So, I mean, they've got great documentation, great examples. Once you start to understand the fundamentals of how containers work, you'll understand that -d is detached mode, means you're not attached on the terminal anymore. So, yeah, super helpful. Anybody else while I'm stopped here? You keep going. You got a question? Yeah, so this is going to be running the files that we copied when we did way back here where we built this image. So we copied dot, which is the local directory we're in currently, into var www html. Yep, and it's not even mounted. It's actually just copied as we built the image. So I was kind of talking earlier about volumes. When you mount a volume, it's a two-way bind typically between the host machine and the Docker container. So when things change in either, they change in the other, right? That's good sometimes. But in this case, what we wanted to do was just take those files once and put them in the container and not have it send back to the host. Yes, exactly. Yeah. So that's right. We are serving the containers file system in this case. Yeah. I know it's a little. The volumes and the like copying and stuff it gets a little hairy, and you got to figure, get your head wrapped around it. But yeah, good questions. Thank you. Okay, so that is very complicated to do all these Docker run commands. Remember all the flags to set. Don't do that for long. Do it once to learn it, and then don't do it anymore. So the real way you're going to do it is with Docker Compose. Whoops, I just jumped ahead. Okay, the real way you're going to do it is with Docker Compose. We're going to come to Docker Compose in a second. I thought that was next in the slides, and I'm losing it today. All right, so we're going to talk about env files real quick. So one other thing that I've found really helpful is at some point you're going to need to load environmental variables into your container, right? I like .env files for local development. They're not great on the server necessarily. There's lots of reasons you maybe shouldn't do it. But for local development, you can say docker run --env file equals .env, and that loads all those environmental variables from the local .env file you have into the container. So don't check that .env file into version control. Just have it running locally and git ignore it. And then use docker run and tell everybody, you know, here's the env file you need. And copy that over to developers in some secure way. Are you all familiar with env files? Is that something pretty standard? I know like Laravel likes it, but not every PHP developer uses it, so I don't want to assume. Anyway. The other thing you should know is that once you build a Docker image, you can share it with people, and that's really one of the most powerful things about these Docker images. And we do that through Docker registries. So Docker Hub is the most notable or widest used one for open source because it's free for open source projects. All the major cloud providers have their own private registries that you can use. So Azure and AWS all have some kind of private registry where you can share your Docker images internally with a team. And what you do is you build the Docker image locally or on a continuous integration environment, and then you push to the registry, and then everyone that needs that Docker image just pulls. So it can be something you set up to do automatically on a daily basis or as needed. You can just pull the latest Docker images, and you're guaranteed to have the latest version of the code. So it's super helpful, similar to how you would do with the git pull. Similar idea. And then a couple other commands that are helpful before we get into Compose. Docker PS lists all the running containers. So at some point, you're going to have like a bunch of containers running. You're going to want to see what's running on what ports and things like that. Docker PS will help you out there. If you want to stop a single container, it's docker stop and then the name of the container or the ID or the first few characters of the ID. Docker's pretty flexible about that kind of stuff. If you want to inspect and see what environmental variables, what resources each container is using, you can say docker inspect and the name of the container. If you want to execute a command, so a lot of times what you'll want to do is kind of SSH into a container, which is not a real concept. You can Google that, and what you'll find is docker exec. And docker exec allows you to execute a command. It basically, what it's doing, and there's this -it flag, is it's not even connecting to that container's shell. It's really copying that container and connecting to that copy's shell. And I think the reasons for that is, once again, Docker is only running one process per container. And if you want to run docker exec, you're running a new process. You're going to say, like, docker exec, IT, the name of the container, and then what you want to run, which might be bash or something, or vim, if you want to look at a file, or tail, if you want to tail something. Anyway, you can look more on Docker's documentation about exec, but it's handy, comes in a lot, so I mention it here. And then finally, tailing the logs is also going to be really helpful. So Docker logs -f, which follows the logs, and then the name of the container. Cool. So there's a lot of other things you can do there with Docker commands, but I haven't listed all of them, just some of the highlights. So we learned all this stuff and how to do all this stuff manually. This is building a custom image, running a MySQL container, connecting those two containers, pushing images to the registry, and then customizing our env files. All this is great, but Docker Compose makes all this way easier. So I teach all that stuff or say all that stuff just to get us to this point where likely you're going to be using Docker Compose more on a day-to-day basis. And the way Docker Compose works is we say we have one Docker Compose YAML file. We say Docker Compose up, and it brings up all the containers we want with all the configurations already set in them. So this saves a ton of time. We don't have to run Docker run 5 times to get 5 containers running. We just run Docker Compose up, and it's all running. And the reason I don't mention that first is that it abstracts away what's really happening under the hood. And I think we should all kind of know what's going on under the hood. So at least run through a couple Docker runs on your own, and then build a Docker Compose file. And this is what one looks like that does roughly the same thing as what we saw in that previous example. Only difference being I'm using MariaDB, and I just noticed that I'm using a different image. But Maria and MySQL are going to be pretty similar, pretty much the same in most cases. So that's Docker Compose. Again, the downside to it is that you've got an abstraction layer, so you're kind of hiding some things that Docker's doing behind the scenes. But I really like Docker Compose for most things locally. OK, so at this point, this is pretty much the basics of what you need to know to run Docker locally. Now, there's like I said, there's kind of a ton of branches of things you could dive into more. You could dive into composer packages and how you would install those and mount those. We could talk about that. You could go into what other services you're going to use. Maybe you want to use Nginx instead of Apache. Maybe you want to, I don't know, what else? Attach caches. You want to do some kind of JavaScript build process. Like, I know I didn't mention all that stuff, and there's tons of good stuff we could dive into later. I will mention a couple things about running on a server, because I think that's one topic that gets a lot of questions, and so I think it's worth bringing up. Before you get into running Docker out in production, a couple things to think about. Data persistence. So are you going to mount volumes for your persistent data from a host machine? If so, how are you going to keep that host machine alive and running? Do you need to worry about any certain secure container options? Like we looked at that -E and that MySQL allow empty password. Don't do that in any kind of production. Think about all the smart ways to set those environmental variables. You need a plan for orchestrating those containers, and orchestration entails several things. It's building up the latest version of the image. It's deploying it out to a system. It's making sure it stays running. It's getting any secrets deployed to the right places or allowed for the right containers, and then networking all your containers together. And then finally, do you even need Docker in production, or is this just something superfluous? And I think it's a great idea, and I actually think there are plenty of good cases. Again, if you're having a lot of trouble with parity between local machines and out in production, Docker can be a big help there. If you have needs to scale up and down really granularly, or if you have limitations on what kind of hardware you can run on, then maybe you just install Docker on that hardware, and then you can run any software you want on it, because you're kind of containing yourself a bit. So, but if you don't, you may not need it. It may not be that useful. Another question that comes up a lot is, how do we host Docker containers? So there's kind of a spectrum here. At the most flexible end and hardest to set up is bringing your own virtual machine or your own actual physical hardware and installing something like Kubernetes or Docker Swarm on it, and then managing it yourself and making sure it stays up and making sure all the secrets are set and that automated deployments work, all that good stuff. All of the big three then have some sort of, I guess I'd call it like middle-of-the-road solution, where it's like they manage Kubernetes for you, and you just give them all the containers and you set it up in there. I've seen it done on Google. It looks pretty cool, because Google's kind of at the forefront of Kubernetes. That's kind of their project. But AWS and Azure both have their own Kubernetes system as well. And then there's some interesting specialized services, which I really like a lot for little projects. So I use HyperSH, and then I've heard of Sloppy.io is similar. And what those do is they essentially allow you to run a container as easily as you would run it locally on their hardware. And so it's kind of the serverless version of container hosting, whereas I would normally say Docker run and then give you all the info about the PHP container. I can say hyper run, and then it automatically is running a PHP container in the cloud. So it's super fast and simple to get running. The downside to those is they're not nearly as flexible or sort of, I don't know, enterprise ready. They're good for hobbying around. I don't know if they're quite there for production environments yet. Cool, so that's it. Slides are up at pcto.co/ne-php. You guys take a picture and look at that. I am happy to dive into other questions. We've got a couple minutes here, so anybody have anything else burning? And thank you so much for your time and coming. Yeah, thank you. Yes, sir. Yeah. Yeah, so when you create a local environment and you want to share that environment with someone else, typically what I've done is shared the Docker Compose file. So if that Docker Compose file is checked into version control, which as long as you don't have actual environmental variables in the Compose file, which you should try not to do if they're secret, then you can just check this into version control at the root directory of your project, and anybody who comes in that has those Docker images or access to those Docker images will be able to say Docker Compose up, and it's up and running. Yeah. That's the easiest way. Yes, sir? Oh, very good question. So if the PHP container wants to talk to the database container, which port is it using? Because in this case, we've got a port mapped, and we've got the original port. So it's either one, which is not necessarily the right way to do this in production. But for local development, you can argue that it's fine. What typically you'd want to do if the database is only ever going to be connected to from that PHP container, you would not want to open any ports at all and just allow the Docker network to deal with that. So basically then your PHP container would be allowed to talk to the MariaDB container because Docker Compose puts them in the same network. Yeah, so this is kind of another one of those like gotchas for production environments, because if you're not aware of how Docker's putting things in networks, you can accidentally allow too many containers to talk to each other. Now there is a way in Docker Compose to set up multiple networks that can't talk to each other, so you can isolate. But Docker Compose is it kind of got an interesting journey. It started off as just a local development tool. People tried starting using it in production to deploy things, realized it wasn't really good for that. Docker built this thing called Swarm that is an extension of Docker Compose that is supposed to be ready for production. And then Kubernetes came along and just ate their lunch, and they said, OK, we're just going to support Kubernetes. That's the way to go forward. So Docker Swarm still exists. You can actually run Docker Compose in production as well. But Kubernetes seems to be the way that everyone's pushing. And Kubernetes has its own solution for networking pods together, which are clumps of containers. See, this is a whole thing. Like, I don't, that's why I try not to get too far here. But that's a really good question about how those mappings of ports go. And typically local development, you're not too worried about what ports are allowed to talk to each other typically. But that's really good. You can look into Docker. They've got a whole networking section of rules and stuff in their docs. So. Yes, sir.
I had a little bit of the same question, but so are those two containers that you're defining Docker Compose file, are they just linked by magic?
Yeah. Yeah, so are these two containers linked by magic? The answer is yes. The magic of Docker Compose has decided to link them. And you see how down here at the bottom I've got this volumes part? This is defining named volumes that can be used by any of these containers. There's a similar construct for defining a named network that could be used by certain containers, or you can say add each container to that network. And that's the way you deal with that problem if you want to have multiple networks going. Yep. Awesome. I'll hang around for a couple minutes till the next speaker walks up, but thank you all so much for your time and showing up, and enjoy the rest of the conference. Thank you.